brick down there.
It's high-tech
Yeah,
wire
it's nice.
harness.
It's a harness.
Welcome to Purdue University and the Security Seminar, sponsored by CERIAS. Today our speaker is Ed Finkler, spoken on topics related to web application security at a number of conferences and workshops. And today speaks to us about a multi-layered approach to web application defense. Best of all, Ed works for us at CERIAS. He's our webmaster. Ed?
Hey. Yeah, I do the web stuff for CERIAS, and what I'm going to try to talk about today is kind of a meat and potatoes talk about a multi-layered, kind of multidisciplinary approach to defending web applications. It's going to cover a lot of disparate areas. Some kind of network architecture stuff, some hardware stuff, server software configuration, programmatic stuff. Basically, what I'm trying to get across with this is to give kind of a feel for what are the kinds of things that go into web application security. What are the different areas, things that you need to think about when you're doing that. So yeah. It's web application defense. I don't know if I'd go so far to say it's any more complex than other issues. It's not. There's certainly more complex things in the area of information security, but it's interesting and can be challenging because of its multidisciplinary nature. To defend web apps properly, you really have to have a team of folks who have good understandings of configuration of hardware, network architectures, operating system configuration stuff, server daemon configs with your server softwares, web servers, database servers, things like that, and also programming. The issues of secure programming techniques and things like that. The first kind of thing I'm going to touch on is what is usually a term that people cringe at, is security through obscurity. And I don't think it's a good thing to rely on by itself, but it can be fairly useful in certain circumstances as sort of a way of staying out of the firing line. Basically, the idea is that you kind of keep quiet and you don't want to attract attention to yourself by announcing information about what kinds of things that you're running. There have proven a number of, an example would be the Santiworm that attacked PHP BB installs. What it did was it actually used Google as sort of a reconnaissance system and would search for version strings of a particular web application called PHP BB, would look for, and those are displayed on almost every install unless someone had customized the template to take that part out of it. So every install of this application, which is quite a popular bulletin board application, would display a version string at the bottom of the page. Well, it would use Google to search for that version string, try to identify vulnerable installs of this, and then would attack them automatically. Basically, the idea here is that you don't want to give out those kinds of that kind of information. So you want to turn off all of what I'd call server signatures. Those would include things like if you're running a web server and in the headers it reports that you, by default, let's say on an Apache install, it will report what version of Apache you're running and all of the modules that you have running. And at very least, I think it will typically include the OS. It'll include the OS you're running, and like if it's what the Linux distro, it'll include that distro and what version you're running of that and that kind of stuff. With a tool like Apache Mod Security, which we'll talk about in a little bit, which is an add-on module for Apache, you can disable that entirely, or you can change that to any arbitrary string you want to. It makes it a lot easier to do it. Otherwise, I believe to change that string to something else I believe you have to actually make a change to the source code of Apache and recompile it. You may also find that sometimes the scripting languages that you're using are inserting info into is reporting information about that. PHP by default, I believe, will report itself and insert something into the HTTP headers that says, you know, X PHP version 5.1.2 or something like that. So again, you want to go into, if you want to examine those kinds of things in your web application stack, and find the information that's reporting and pull that stuff out in any way that you can. It's obviously it doesn't actually really defend against anything, but it keeps you from attracting attention. And then sort of a final thing was turn off any error reporting to the browser by it's a typical thing that you don't want production machines to actually report any kind of detailed error information back to the user. Obviously, you want to log that, and you'll log that in internal system logs and stuff like that. But if you've used, you know, plenty of web applications, you'll probably often see you'll run across, if there's some misconfiguration or problem with the server, it'll report out something like, you know, error at line such and such on, you know, in this file, and it'll give a full path to that file. Well, that's an information disclosure issue, and it may not be a huge thing, but it may give an attacker some ideas about what kind of system they're working with and potentially what kinds of things they should be looking for to get into it. Most of the stuff I'm going to focus on here would be dealing with an open source software web stack, which is generally, it's some kind of Unix variant, CERIAS or Linux. Those are the ones that we generally run at CERIAS. Almost all the time you're going to be running Apache. There's a couple other options, light HTTPD, stuff like that, but generally Apache is by far the most popular web server you're going to see. For your application logic, you're going to be running probably one of the P's, PHP, Perl, Python. Some folks will run Ruby, and Ruby on Rails is a popular application framework built on Ruby that is used often. It's gaining some popularity. And then some kind of database server. I'm most familiar with MySQL and PostgreSQL, but there are certainly, you know, you may be running some commercial stuff, Oracle, DB2, MS SQL. Most of these things are going to be, most of the techniques and the kinds of things we're talking about are going to be applicable to a number of setups, even if, say, you're running IIS with ASP.NET, something like that. So these kinds of things are going to be applicable in most cases, but my strongest familiarity is with these, and it'll probably be mostly applicable to that. The first kind of line of defense you're going to see are firewalls, and that's a common thing. Everybody's, you know, it's expected that you're going to have some kind of network firewall that's filtering traffic, you know, set up, and that would be a key part of a network architecture. OS level firewalls are going to be common too. Something like the Linux IP table stuff that's built into the 2.4 kernel and above, things like that. What I think is kind of a new thing is more particular to web applications are this idea of web application firewalls, and these are a little bit different in that they don't just necessarily filter, say, what ports things are coming in on or what types of packets you see, but generally what they'll do is they actually are going to be able to scan the traffic that's coming in, the payloads that are being sent from clients up to the web server, and they're going to scan that, and you can build it. They'll work differently. The one I'm going to be talking about is mod security. And with those, what you can do is you basically build up a set of rules that it basically compares the incoming traffic to, and also potentially the outgoing traffic, and does certain things. Or it throws up an error message, or it throws up an error and stops the execution of that request, or it logs it out, or things like that. So, you know, a basic simple diagram for that would be something like this. And I think the important thing here is that you've got a network firewall appliance, you've got your firewall running that's on an OS level, and you have a web application firewall. So you've really got 3 levels of defense before you even hit your web application. I think that's a key thing, and what I kind of want to emphasize over and over is you're going to through a lot of this you may see redundancy where we're basically defending against the same kinds of things 2 or 3 times. But the idea is if you screw something up in one place, hopefully you won't screw it up in the other place. You hope. Or if you miss something on one level, it can drop down, but you've got another line of defense before that. So mod security for Apache, that's a really, really good tool. And it's at the point where I feel that if you're running Apache, you're running, basically I think that it's a requirement. It's not part of the standard Apache distribution as it is now, but I would not roll out an instance of Apache running without it. It's a very powerful open source web app firewall. There is commercial support for it, so you can, if you know you're working in a business or enterprise level and they want that, you can get those kinds of things. But like I described before, it basically intercepts, examines, and acts upon incoming and outgoing payloads. The data that, say, a web browser is sending to the server, and it's important that it can do both incoming and outgoing. We'll talk about that in just a sec. It also makes what they call chew routing, where you are restricting what the web server can do within the system, and changing things like the server signature, which we talked about before. It makes doing those things quite a bit easier. That's one of the nice advantages of mod security. It has a few different features like that, but primarily the interesting thing is its ability to filter and act upon certain things. So actually this might be misleading because I'm not sure that it actually does any sanitization. I should probably change that. But what it can do is, again, you're going to get input from some arbitrary client online, and it will come in to your web application, and Apache is going to, the mod security in Apache is going to look at each of the different sets of information that you're getting and look at it. And it could be something as simple as just a regular expression look to say, okay, if the information we're getting contains this kind of a string that is indicative that this might be some kind of attack that they're sending, reject that, or log it, or do a number of actions on it. It's not on by default, but mod security can also do the same thing for output from the web server. So that if for some reason in one of these levels, whether in the web application firewall level or within the web application itself or what have you, if for some reason a malicious user gets your web application to spit out something bad back to a browser, it can catch it while it's going out. So it can examine that stuff and do the same kinds of things to it, either log or deny the request or what have you. So kind of keeping Apache on a leash. The key things that I see for this are if you have dynamic code, that would be if you're writing something, say like in PHP, Perl, Python, that kind of thing. I really always recommend that, especially on what we call shared servers, that you do something that compartmentalizes it so that particular applications or particular, say, domains or things like that, you compartmentalize them so they're running under different user accounts on the system. The idea with that is it's sort of like on a ship where you have, you can, what do you call that, where you close off
Batten down the hatches?
Yeah, you batten down the hatches, and it's compartmentalized, so you can close off certain sections of the ship. So basically, if one gets punctured and it starts flooding, if somebody has some bad code on their system, and on your system, and has a vulnerable web application, that can't be used as a way to get into the entire system and affect other users on there. And that kind of thing. It basically compartmentalizes it so the damage is restricted to potential damage is restricted to what that user account can access. And obviously you set it up so it can only access what it needs to. So that's why it's particularly important on shared servers. If you ever have an opportunity to look at setups for most popular web hosting setups, they have maybe 100 users, 100 different accounts on, and 100 different virtual domains running on a particular machine. If you aren't doing something like su-execing it, or doing something where you're wrapping your CGI so that they're executing on a particular user and each one of those is executing under a different user, you have a real potential for one web application that's under one user's account to take out the whole system, and it becomes a real problem. So that basically, again, that kind of compartmentalizes stuff. The other thing is chi-rooting, jailing the Apache, is basically keeping the Apache processes, your web server processes, from accessing files outside of this jail sort of root. So if you have Apache set up to sit in a particular directory on your system, 2 or 3 levels down, you would set your root level at a certain point, and then the Apache process, which includes any of the dynamic stuff that it's doing, any dynamic code that people have written, PHP scripts, Perl scripts, Python scripts, Ruby scripts, things like that, they're not going to be able to go outside of that structure. So they're not going to be able to go up and say, oh, I want to go up and go into the etc directory and start mucking around and looking at configuration files and password files and stuff like that. And as I said before, mod security, or there's one that just is for this called mod chi-root is another module for Apache. Make this a lot easier. To do it by hand without these modules is much more difficult. It's possible, but it takes 2 or 3 pages to to write out how you do it, and it's a lot easier to do it this way. So we're going to talk about some kind of programming techniques here where you're talking about web application development when you're actually writing the applications themselves in Perl or Python, what have you. The basic kind of idea here, and a basic sort of mantra for this, is that you filter everything coming in and you escape everything going out. And only when you are, well, I wouldn't even say that. I was going to say only when you're really sure do you not do that. But you have to be very careful of that and very aware of it. But and with this diagram, what it kind of shows is that you have a few different, the kinds of things that are coming in. You're going to have things that are coming in on a few different levels. On the get level, they call that in the HTTP protocol. The post level, cookies that are stored in the browser, and also file uploads, things like that. And the web application itself can spit out things, and these are the kind of things that get spit back out from the web application that can do nasty things to the client or trick the client into doing things that are not good. It's going to be able to send things like HTML and CSS. Those kinds of things are generally not too worrisome. But JavaScript that gets executed by the client is potentially very problematic. Especially, typically JavaScript has access to your cookie information, can take that, can read that stuff and then say pass that information on to another server, things like that. Plugin content is a problematic thing. That was, I don't know, was it a month and a half ago, where there a hole that was in Flash version 8 was exploited on, well, there's actually been a couple things on MySpace, but a recent one was a banner ad that was put into rotation on MySpace, a Flash banner ad, utilized a hole in the Flash plugin that allowed this banner ad, but basically a little Flash applet, to install spyware on people's Windows machines. And supposedly there was some statistics to indicate that there may have been up to 1 million infected machines based on that. But one of the problems that you see with MySpace in particular is that they allow people to embed arbitrary plugin stuff by allowing them to put in the embed tag, so that people can put in things like Windows Media Player, applet stuff, QuickTime, and Flash things. And if there are any vulnerabilities in the plugin architecture for that, then it's extremely problematic. And then cookies are the same thing. A web application can kick back and set a cookie, and that potentially could have some kind of malicious information or malicious kinds of stuff in it, and make the client do bad things. So filtering at the code level, how you're going to do this is going to vary a lot based on the language or framework that you're using. There's a couple different kinds of levels where it can happen. A lot of frameworks will have some kind of level of built-in escaping where it tries to filter information by default. That can work decently, but is not something I put a notice for suspect on there that I would tend not to rely on it too heavily unless I became very familiar with it and was absolutely certain that it was working very well. That it was. I don't want to rely on built-in escaping. Just assume that things are working great. Most languages and/or frameworks are going to have some kind of regular expression library that'll allow you to do complex matching and/or replacement. Those things work very well, but they tend to be very complex. I've got a piece of code here that what this does is it matches a valid email address. And you can see that's fairly long and hard to read. I'm pretty familiar with regular expressions, and that's kind of hard to understand. If I look through it and break it down, I can see what's going on. If you're not, it's really hard to do. But if you don't have other things available to you, most frameworks are going to have some kind of regular expression libraries in it, and that's pretty much what you have to work with to do proper filtering. With higher level stuff, you may have, with some frameworks you may have higher level filtering libraries. An example of this is a PHP framework, the Zen framework, that has a Zen filter class in it. And the example here is a method called test email, and you can just pass it the incoming value, and it says, hey, is this an email or not? Or it can do things like just return all the alphanumeric characters, or just the alpha characters from a value, or just the numbers, things like that. Strip HTML tags out, things of that nature. So that's kind of where you do stuff programmatically. When you get into, one of the things is most web applications probably have some kind of database element that they're using to store data. That typically most web applications have to deal with storing and retrieving data for people. And there's a couple things that you can do that really help with avoiding what's called SQL injection, where somebody passes a value that is then inserted, that's placed into an SQL statement, and then that's executed and does something unexpected, not in the intention of the programmer, because they did not filter it properly. What I got down here is some SQL code, some Java code that uses something called prepared statements. And if you've done much with database work before, you might recognize these kinds of things. And it shows an example of something that is susceptible to SQL injection and something that's not. The advantage of using prepared statements is that it's going to pretty much solve all your SQL injection problems. It automatically escapes all the values that get pushed in, so that it's not going to be able to do something funky like you're trying to just do a select against a particular table just to get out some information, and the string that gets passed in is formatted in such a way that it, say, reads out all the passwords to the user or something like that, or bypasses the standard authentication things or stuff like that. What you can see here in the protected from SQL injection one, the statement has sort of a placeholder. It says select email from the member table where name is equal to, and then it has a question mark, and that's the placeholder for it. And then it uses a function to set what the value is for that placeholder, and then returns that. Again, using prepared statements is going to bypass your SQL injection stuff almost entirely. And unless your framework, for some reason, just doesn't support it, you really should be using these. There are a couple that don't. I think Ruby on Rails doesn't support prepared statements properly, but there are some other similar kinds of escaping that it can do, that kind of thing. If you don't have prepared statements, generally you're going to end up probably manually escaping input values when you put stuff together. There's some, in general, you're going to probably end up having to manually escape stuff sometimes. And that's going to vary. This is a little piece of PHP code where somebody was just doing a select. Somebody's just doing, say, building an SQL statement, a select that would go to a Postgres database, and you're using a function called PG escape string. That what that does is that escapes any funny characters in the value so that it can't do anything weird like manipulate the SQL so that it does something other than what the program intends. Again, that's going to vary quite a bit, or at least what the functions are is going to vary based on what language you're working with, what framework you're working with. But if you don't have prepared statement support for some reason, that's what you're going to need to do. Some more advanced stuff that you might do when you're working with SQL. You might look at doing stuff with stored procedures. What they basically do is encapsulate a bunch of SQL logic, a bunch of database logic into a single function call, and it's actually stored in the database server itself. It makes it a lot harder to do SQL injections, although it's still possible if you're not careful. But you can also do a fair bit in terms of setting permissions, depending on the database server, but in general you're going to be able to set permissions so that certain users can only, say, run certain stored procedures, things like that, and that's very advantageous. The other thing, and something I really find very useful, and unfortunately I don't see used a lot, are views. SQL views are sort of these they're kind of a read-only sort of virtual table that's based on a query that you run, and I have a little fancy diagram for that. We've got an internal table, this internal personnel table that's in our database server, and it has some information in it, and we want to get that information, display some of that information out to a website. It also has some information in that table that we don't want getting out, like we don't want to give out things like, let's say, their PUID number, because that's supposed to be sort of secret, and things like their home email and phone and address, stuff like that. So instead of just one way to do that, and a common way of doing that is, well, you just do your select against this same table, the internal personnel table, but you just wouldn't pick those fields. Well, one way to make it really sure that you're not going to be able to do anything, that nothing bad's going to happen, is you would create a view, and it might be set up in a whole separate section called public personnel, you could call that. And this view only has the information that that you want to be public. So say first name, last name, title, work email, work phone. And the web application, in this case, only would have permission to select and do queries against this public personnel table. So that way, it basically mitigates any issues that you would have with potentially overwriting data or something like that, because it's read-only, and it only contains information that you're okay with being publicly available. That's an approach that we've used at CERIAS, and I think it's worked out very well. But I don't see a lot of folks do that, and I kind of wish they would. Part of the problem is that, especially in open source circles, the most popular database server is MySQL, and only with the version 5, which has come out and been released as a production release, have views even been supported. And I think that's part of the reason why you haven't seen that, at least so much in open source circles. And then basically the last things I'm going to talk about a little bit is database access stuff, and keeping it on sort of a need-to-know basis, and that's a general principle you see all the time. But implementing it for database servers, these are sort of some specifics for that. One of the things I find that a lot of web applications don't do is, and I think that they should be doing, is setting up multiple database accounts with different access capabilities. Most web applications are either entirely read-only, or the vast majority of it is read-only. You're going to be doing selects out of the database. You're going to just be pulling data out of the database. You're not doing any manipulation of the data. You're not changing data in there. So there's really no reason why those queries, especially if that's the vast majority of the queries you're doing against the database, there's no reason that the user who's doing those queries should have any kind of write access. There's no reason that they should be able to insert, they shouldn't be able to alter tables, they shouldn't be able to create tables, they shouldn't be able to do any of that stuff. So what I would do is, if you have a situation where you have a web app that, and most of the time this is the case, that most of your stuff is going to be doing reads, and maybe you have occasional inserts for one thing or another, I would simply set up multiple database accounts. And you would have one that's very restricted, can only do reads, can only do it on certain tables. Potentially, you could do it only on certain columns, things like that. And then you just use a different user for doing writes. But you don't see that too often. Bare minimum host access. The ones I'm most familiar with are MySQL and PostgreSQL, but I'm certain most of the commercial stuff can do it too, where you can restrict certain users to only come from certain hosts, and if they're coming from this host, they have only certain capabilities. There's no reason that a database should be left open so that, say, any arbitrary IP should be able to access it. If your database is hosted on the same machine as your web server, there's probably very little, there's no reason that you should have any kind of networking enabled on it at all. It can just use local sockets to connect. There's no reason that it should have TCP/IP stuff enabled on it. If you had to do administrative access, like from a desktop app or something like that, you could do an SSH tunnel and get in that way. But there's no reason to have those things turned on, and typically I see those things turned on and given way more access than there should be. And then your SQL box, if you got it as a separate box, one approach that I've taken, and it's not always going to be useful for everybody, it's not always going to be possible in every case, but that you set up a network architecture where your SQL database is only going to be accessible from your web server. And I have a fancy little diagram for that. So we have a few basic desktop machines on our local network. We have our Cray supercomputer, and then you have a web server set up, and then you just simply have a private connection over a second. The web server would probably have two Ethernet interfaces and would be running a private connection to the DB server. So that the only way that someone's going to be able to get into the DB server and potentially compromise it is that they first have to go to the web server and compromise that. And hopefully, with all the levels that you build up, that's not going to happen. So that, especially if you have private information there, things like credit cards, username and password, private information, things like that. We've done this in the past, and it's a very effective way of keeping. It really restricts people's ability to get into that thing, and makes it a lot more secure. So that's pretty much it. I went probably kind of fast, but do people have any kind of questions about things? I think. I'm sorry, could you hit your button so I can hear you a little better? Sorry.
What type of interesting attacks have you seen coming in?
Interesting attacks have I seen. There's a general trend. The first thing is that there's a general trend. And if you look at SANS 2005 Top 20 Vulnerabilities Report, there's a general trend away from OS level attacks towards application and web app attacks. And attacks moving away from vandalism towards focused attacks that the purpose of which is to almost always retrieve private information that can be used for financial gain by criminals. That's the key thing. So you're seeing these attacks coming through things like, but coming through applications. Generally, especially on the Windows level, what you saw is that, or on the Windows level, with Microsoft has finally gotten to the point where they've done a pretty good job of locking down their OS. It is in a much better state than it was 5 years ago. And so the situation you have is that people kind of moved away from that. Now the problem is that web applications and other kinds of applications like media players and things like that, 5 years ago, generally we didn't think that much about security. I can tell you that 5 or 6 or 7 years ago, the code that I wrote was wildly insecure. I didn't think about SQL injections, and I didn't think about things like cross-site scripting stuff and things like that. So that's a sort of a major change that you're seeing. So there's a general thing towards web application attacks. I think that you're going to. My suspicion is that you're going to see some of the kinds of stuff you've seen before, where you'll see leaks of private information coming out of particular targeted firms. Like, okay, there was some leak where, say, 20,000, user records were left out that contain social security numbers and things like that, or credit card information, things of that nature. I think you're going to see attacks against, you're going to continue to see attacks against social networking systems, because those are very popular, and they are places where collected information about information about users is being collected together, and it's very easy for some kind of worm or viral kind of attack to spread, because of the nature of it is that users are all linked together in a big network, and I think you're going to continue to see that. So far, the most of the attacks that you saw that were, say, on the MySpace system have been, well, no, the spyware one certainly wasn't. That was a particular that was certainly malicious. It wasn't really a proof of concept thing. But I think you're going to see more stuff like that. You're going to see them targeted at. They see a site like MySpace as a great piece where, one, the design of that web application that is MySpace is quite bad in terms of filtering input. They take what's called a blacklisting approach, where they try to strip out bad information coming in, as opposed to stripping out everything except stuff they know is okay. And they've built an extremely large user base that expects their system to work that particular way, because they like to be able to do things like embed arbitrary HTML that lets them put music videos on their pages and make horrible eye-burning backgrounds and animations and stuff like that. And they expect that. And with the nature of this kind of a business that those folks are in, is that they don't want to do anything to upset that and potentially start losing some of that user base. So they're motivated not to correct that problem. They're going to have to keep kind of patching it and hope that they can keep blacklisting certain things. Well, unfortunately, that's generally not going to work. So what you'll see is a site like MySpace or other sites like that have lots of collected information about that are going to be very good vectors of attack for either retrieving information about something, about people, or gaining access to, say, their local machines or things like that, like was done with the Flash banner attack that exploited a hole. And I think you're going to see more stuff like that. And I think you're going to see it get worse before it gets better. So I think you're going to see more stuff of that nature. Does anybody else have any other questions?
Can we ask a question down here? Can you hear
Yeah.
So, I mean, these are all great things in terms of defending systems, but it seems to me it's sort of like, at least for the vast majority of systems being developed, you can do all this, but it doesn't stop the primary project developers from coding in a big security hole right through the middle of everything. Because, you know, the people tying the systems together do whatever they want to do to keep things secure, and they might be security experts, but the actual web app developers tend to have no idea what they're doing security-wise.
Hey, I'm a web app developer, so be careful.
Well, I didn't say all of them. I said
No, I understand. No, I agree with you entirely.
So, you know, you're talking about social networks, and today the big issue is with Facebook, at least on this campus, and all of the changes they just made to their policy. And while they wouldn't necessarily be security changes in terms of computer security, they definitely affect student security.
Yeah.
And you know, it seems there was no thought put into it whatsoever.
No.
So I guess the question is the following: I mean, you've got a lot of expense to do everything you just described, because you're going to need someone who's an expert at security to do it all. Most companies aren't going to hire those people because they're too expensive.
Maybe.
And even if they do, the web app developers probably put a hole right through the middle anyway. So do you really see web apps getting more secure?
Well, they have to, or we're screwed. I mean, that's not to be blunt or harsh about it, but do I see them getting more secure in the next 6 months? No. Do I see folks starting to take security more seriously within web application development? Yeah, I do. I think that there's a general trend towards that. But I also see that, yeah, the majority of web app developers that I run into don't know much about security still. They sort of start to hear about some stuff, but it's they don't really have a good understanding of it. But it's the same kinds of things you're going to run into just as a general application stuff is, do your programmers know how to write secure code or not? If they don't, there's a problem, and that's not really, I didn't really address that necessarily in this talk, but I've done some other talks that have tried to talk about that. Of course, they've tried to talk about it because it's a talk, but that have brought up these issues and talked about that there really has to be sort of a multi-pronged approach to it. That you not only need to do improvements in terms of the development frameworks that folks are using to develop web applications to make it easier to write secure applications, but at the same time also doing a lot in terms of educating developers about those kinds of things. I am not super familiar with, say, most of the, when I went to college, they didn't have web application development, but my impression is that they're not pushing security as a particularly important feature of programs in that area, and I think that's a serious problem. I think that has to change. I think that academics have to make a significant change in terms of that. I think that people who are doing hiring have to have some understanding of what to look for in a developer. And if they don't know the right questions to ask, then they're not going to ask them. I'm not generally a big fan of certifications. I think a lot of certifications don't make a whole lot of sense. But there are some certifications that do make sense. And I think a good example of that is Zend, which is a commercial company that supports PHP stuff, has a certification program that includes quite a bit of security information on it. I think that's a certification that people should be looking for, because I think engineers who have passed that demonstrated that they know what they're talking about and they understand security issues and other, obviously other web application development issues. Yeah, I mean, part of the reason why you make it multi-layered is that there's a good chance that somebody just isn't competent and doesn't know what they're doing. If they don't know how to set up the firewall, then, if they don't know how to set up the firewall application, or excuse me, the firewall appliance, things are going to get through and you have to address it at other levels. But yeah, it's a serious problem. I'm not sure I have a great answer for that, but I think there are some key things that we should be doing that we're not. And I know I will continue to try to talk to folks who are developing curriculums and things like that to hopefully get them to consider secure programming as a key part of any web application courses, web application development courses. So, I don't know if that answered your questions at all, but.
Any other questions? Okay, thank you very much. Anyone come in late need to sign the attendance sheet?